So far, all our linear equations have had a single variable term or factor, so we could use the two-column table to solve the equation. It's common, though, for linear equations not to start with a single variable term or factor, and so we have to collect like terms and simplify before we can use the techniques that we used earlier. When I have variable terms on both sides, it's hard to see what the answer should be because I have two terms with, in this case, k. I'd like to have just a single term in k. To do that, I'm going to subtract 5k from both sides. Now, you can actually subtract 6k from both sides if you prefer, but what I always do is, when I'm going to combine variable terms, I look at the coefficients, and whichever has the larger coefficient, that's the side I keep the variable on. That way, my coefficient is always positive, and I just find it easier to work with positive numbers. In this case, I'd like to have k on the left, since 6 is greater than 5, which means I don't want 5k on the right. Well, to do that, I'll simply subtract 5k from the right, and then 5k minus 5k will be 0. And then 0 minus 4 will just be negative 4. But if I'm going to subtract 5k from the right, I also have to subtract 5k from the left. Otherwise, these two expressions aren't the same anymore. As I mentioned, over here I'll get 5k minus 5k, which will be 0 minus 4, and that'll just be negative 4. And over on the left, I'll just get 1k. Now, if you want to write 1 times k, that's fine. People often don't. The product of 1 times k is k, so they just write k. Now, I want to check my solution, so I return to the original, and everywhere there's a k, I now substitute a negative 4, and I'm going to substitute into parentheses, because you see, this is a multiplication. It's 6 times k. This is also a multiplication, 5 times k. To keep that multiplication meaning, I need to have parentheses when I substitute. Both sides simplify to negative 24, which implies that negative 4 is my solution. Here's one for you to try. Because I always like to have positive coefficients on my variable, I'm going to have the right expression be my variable term. To do that, I'm going to subtract 3y from the left and from the right, and then I'll simplify both sides. Now I check my work, and when I simplify, both of them go to 60. That implies this is my solution. Try this one. Since negative 7 is greater than negative 8, I'm going to have my variable term on the left. That means I'm going to add 8x to both expressions and simplify. To check my work, I'll return. Both of these x's will get replaced by negative 1 in parentheses. When I simplify, I get 7 from both expressions. So my check looks good. Now let's look at an example where we have variable terms and constants on both sides. My goal is to get my single variable term on one side and my constant terms on the other side. That way it's pretty easy to see what my answer should be. I always start with the variable terms, and again, I always have my variable term on whichever side had the larger coefficient. So I'm going to start with my x terms, and since 2 is greater than 1, I'm going to have my variable term on the left. To make that happen, I have to subtract x from the right, and I'll also then need to do it from the left.
Then I'll simplify.
Now, to isolate x on the left, I need to subtract 5 from the left so that this will go to 0, and then x plus 0 will just be x. Of course, I'll need to subtract 5 from the right also. Simplifying on the left, I get x, and on the right, I'll get -7 plus -5, and that'll be -12.
And then I'll check my work.
Try this one. This time, my right variable term has the greater coefficient, so I'm going to subtract 5x from the left, and I'm going to subtract 5x from the right. Last, I'll add 3 to both expressions.
And simplify.
To check my work, I return to the original. I substitute 10 for both of these variables. Again, keep in mind that you're using parentheses to keep the multiplication meaning. 6 times x, 5 times x. Both of these become 57, so 10 is my solution.
Well, that will conclude this video where we've continued working with linear equations.